Hi, so today we're going to be dealing with the two-number sum. Imagine a question is given to you. You are asked to find two numbers within the list that sum up to the number 10. How would you approach this? So the easiest way to go about this would be to pick a number and then loop through the rest to find a number that can sum up to give you 10. If we have 3 as the first number, we're going to be looking for 7. So that means 10 minus 3 equals to 7. Is there 7 in here? Going through to the first one, no 7, no 7, no 7, no 7, no 7, no 7, no 7. That means 3 can't be part of what will be added to make 10. So you simply move to the next. And when you move to the next, you consider these ones now. And that's pretty much it. So that time complexity is pretty much an ON squared. That's quite easy. So we're thinking of how can we optimize this time complexity, and there's a simple way to go about this and kind of uses the two-pointer method. So what we're trying to do is get the two numbers that reach the target number of 10. So what would you do? The easiest approach to go about this is to first sort the array in ascending order or in descending, whichever you choose. So I'm going to sort the array in ascending order, and when you sort it in ascending order, you get -4, -1, 1, 3, 5, 8, 11. So this is it sorted in ascending order. Then once you've sorted in ascending order, you have two pointers, one on the left and one on the right. So you have a pointer here, you have a pointer here, and you are to sum up the values of each pointer to get 10. Now, there's 3 conditions to consider here. -4 plus 11 is less than 10, you increase the left pointer to the right. So that means the left pointer moves to the right. But what if it was greater than 10? You will move the right instead to the left. Why is that the case? Because when you move from the numbers from the left towards the right, you are going higher. And when you move from the numbers on the right to the left, you are going lower. So to make something that's greater than 10 become lower, you simply move to the right. So that means you just say the right pointer, right, minus, minus. And from the left, you say left, plus, plus. So that's pretty much it. So in this case, I'll wipe all this. When we consider the first pointer positions, we have -4 plus 11, and that's going to be 7. So what do? It's less than 10. We move the left pointer higher so that the number sum can increase. And we move here, and we leave the right pointer where it is. Now we say -1 plus 11, and that's 10. The current time complexity of our algorithm is n log n plus n, because there is first a sorting process and a linear process. N can be factorized and we'll have 1 as a constant. And to simplify, we remove the 1, and all we have as our time complexity is n log n. So now we're going to be implementing the algorithm on a code editor. First thing you need to do is sort the array. So you can simply do this. Sort. And once it's sorted, you have to take 2 pointers, one on the left and one on the right. So we have a start and an end. So 0. Now we go through the loop, making sure that the 2 pointers never cross each other. So we can do a while loop here and say start must be less than end always. Now while we're doing this, we simply need to check the sum every time and say sum equal to array start plus array end. Now we have to sum at each iteration. We check if the sum is less than target number, and if it's less than, you increase the left, or should I say you increase the left pointer, which in this case is start, by 1. Well, if it's greater than the target sum, you reduce the right pointer, and if it's equal, you return the two values at that point, which will be this. So that's pretty much it in the iteration part. Then if nothing sums up to the target sum, you simply return an empty list, and that's pretty much it. So on our first try, we should get everything. Yeah, so as we said, sort the array, sort the list, put two pointers at both ends of the list, start and end, then make sure the pointers never cross each other, and at each point then check the less than and greater than position for the sum and the target sum, and pretty much return if it's equal. Yeah, so that's pretty much it. Thank you.